Students, in this video today we're going to be studying a specific type of linear equations called direct variation equations. So the first thing I want you to understand here is these equations that we're going to study today right here, direct variation equations, they are linear equations. They are a type of linear equation, okay? Please copy this heading down if you would, direct variation equations. Lesson 4.5, and be sure and include today's date, alright? Be sure and include today's date. Now, first, like always, let's start off with a definition of what we are looking at today, which of course is direct variation equations. So please write down this definition. A direct variation equation is a linear equation that has only an x and a y term. For example, don't write this down. Go ahead and copy down this definition. While you are copying that down, let me just talk, okay? You guys would not argue with me that this is a linear equation. However, it is not a direct variation equation because we don't only have an x and a y term, we also have a constant term, okay? Now, if this constant term was taken away, then I would have a direct variation equation. Do you see what I'm saying? A direct variation equation is a linear equation that has only an x and a y term. Here are some examples. If you want to copy these down, feel free to. This would be a direct variation equation. Now, Mr. Earhart, you just contradicted yourself. Well, not really, because even though there's a constant term here, it's zero, so really there's nothing there. So this would be a direct variation equation. It only has an x term, and it only has a y term, and it's a linear equation. Do you remember how to tell if it's a linear equation? I've taught you this. If the power of your variables are ones, what's the exponent of x? 1. What's the exponent of y? 1. So this is a linear equation, and we only have an x and a y term. Now, if this 0 became a 10, then it would not be a direct variation equation. Alright? Here's another direct variation equation. That's a linear equation that only has an x term and only has a y term. This would not be a direct variation equation because I do not have an x and a y term only. This would be a direct variation equation because it's a linear equation and I have only a y term and only an x term. Do you see what I'm saying? A direct variation equation is a linear equation that has only, or that only has an x, and you must have both an x and a y term. Now that's what a direct variation equation is. There are some characteristics of these types of equations that you definitely need to know. There are 3 of those. I'm going to put them up quickly like this, and then go on to the next page, so you'll probably want to pause the video, okay? Number 1, they always pass through the origin. Always. So when you graph a direct variation equation, it's going to be linear, and it will pass through the origin. There's the origin. Might look like that. Might look like this. But when you graph a direct variation equation, it will always go through the origin, always. Number 2, if I'm going too fast, just pause the video. You cannot graph these equations using the double intercept method. Come on, guys, that makes sense, doesn't it? Think about it. If you know the graph passes through the origin like this, then let me ask you a question. What is the x-intercept? Where does it cross the x-axis at? 0. Where does it cross the y-intercept at? Or the y-axis at? What's the y-intercept? 0. So if you're using the double intercept method, and all that you have is one point right here, how can you draw the line? You cannot graph direct variation equations by using the double intercept method. Okay, you cannot. The best method, the best way to graph guys, is the slope-intercept method usually. You might want to put the word usually in there, okay? Sometimes a table of values method also works well too. Depends on the situation, okay? But quite often, the best way to graph these is the slope-intercept method, but you cannot graph these using the double-intercept method. It will not work. And they always pass through the origin. I'm going to move on, pause the video if you need to. Now, every direct variation equation has a constant of variation. Here's what that is, so please write this down and take some really, really good notes. Every direct variation equation has a constant of variation. Write this in your notes, please copy this down. First of all, I think we can all agree this is a direct variation equation. It's a linear equation, and I only have a y term and an x term, okay? Now the constant of variation is always the x coefficient. So your constant of variation, please write this down. Your constant of variation for this problem here would be 1/2. Because what is the coefficient of the x? 1/2. Okay, now there's one catch to this, and I hope you'll listen to me and write this down and take good notes, please. The y must be isolated. Write that in your notes, please. I probably should have typed that. Write that down. The y must be isolated before you can find the constant of variation. In other words, copy this down. Is this a direct variation equation? Yes, it is. It's linear, and I have only an x and a y term. So you might look at this and say, oh, the coefficient of x is 6, so my constant of variation is 6. And that's wrong. Y must be isolated first before you can assume that. So divide both sides by 2 to get the y isolated. And when I say the y needs to be isolated, I mean get the y all by itself. Divide both sides by 2 and you get this. Now you can look and see what the constant of variation is. The constant of variation is 3. Got it? 3. So it's really quite simple. In fact, it's amazingly simple. The direct variation, the constant of variation for a direct variation equation is always the number with the x, the coefficient of x, as long as the y is all by itself or the y is isolated. Okay? Now this is interesting. Write this next sentence in your notes, please. The constant of variation is the same thing as the slope in these types of equations. Write that down, please. Please notice this is very important. The constant of variation is also the slope. Because did I not teach you guys that anytime a linear equation has y by itself, something like this, have I not taught you guys that your m would be what here? 2, and your b would be what? Have I not taught you that? Sure I have. So what's the difference if I give you a problem like this? If I gave you a problem like that, is that a direct variation equation? Yes, it is. Is the y isolated? Yes, it is. So what's your constant of variation? 2. But also if I said what's the slope, you would say the slope is what? 2. Listen guys, anytime y is by itself, the number with the x, the coefficient of the x, is always going to be your slope, unless you're not dealing with a linear equation. But right now in chapter 4, all that we are dealing with would be linear equations, okay? So the constant of variation is also the slope. Please understand that, okay? Alright, moving on. Now here is the model, or if you like the word formula, I have no problem with that. Here is the model or formula that we are going to use to help us write direct variation equations. Please copy this in your notes. Y equals kx, and k of course stands for your constant of variation. Please copy all of that in your notes, students, please. K is your constant of variation. Okay? So this is the model we're going to use right here. And by the way, can I say something to you real quickly, please? Would everybody listen to me, please? Focus in and pay attention. Listen to this. If I told you that you had a direct, don't write this down, just listen. If I told you you had a direct variation equation, and I told you the constant of variation was 1/3, could you not quickly write the direct variation equation? My goodness, sure you could. First of all, you know if the constant of variation is 1/3, that means y is by itself. And you know the 1/3 has to go with the x, right? There it is, we did it. That is so simple, guys. That is so simple. Okay? So keep that in mind as we start to do some problems. Now, if you know the constant of variation, you can write the direct variation equation so quickly. So quickly. Okay? And don't forget, K stands for the constant of variation. I think it's so important, I'm going to say it again. Anytime you know the constant of variation, you can quickly write the direct variation equation like I did here. It's simply like this model here where the K is, you would put what? 1/3. And you're finished. Y equals 1/3 x. So it sounds like to me the key is to find the constant of variation. Alright? So with all of this in mind, let's start applying this information to some problems. Okay, here we go. Copy this problem in your notes, please. I'm telling you right now, x and y vary directly. That means we have a direct variation equation, okay? That's what that means. X and y vary directly. Write the equation that relates x and y. So in other words, what that means is we're going to write a direct variation equation. Got it? X and y vary directly. As soon as you read that, you know you're dealing with a direct variation equation. And they want us to write an equation that relates them. So here we go. Notice I tell you what 5 is, or excuse me, what x is. Notice I tell you what y is. Now let's go back a page. What did I just tell you back here? If you want to write a direct variation equation, what's the one thing you want to find quickly? The constant of variation. So let's find the constant of variation. Well, Mr. Aaron, how do you do that? Very simple. Remember the formula I gave you guys? Write this down, please. There's the formula I gave you. Can we not find K very, very quickly? Where the y is, I'm going to put 20. Where the x is, I'm going to put what? 5. So 5 times K times 5 is the same thing as 5K. Oh my goodness, it's so easy to divide both sides by 5. And what's your constant of variation? 4, remember, K stands for your constant of variation, alright? So I solve for K. So students, did I find my constant of variation? Yes, right here. So then write your equation. Y equals 4x. Remember what I showed you back here? If you know the constant of variation, all that you have to do is put y equals and put the number in front of the x and you're finished. Okay? So there you did it. Now, let's go on to something else. Don't forget, here's your answer right here, okay? Y equals 4x. Now look what I want you to do. Now that you've done that, find y when x is 10. Okay, no problem. In other words, where x is, put 10 in. So y equals 4 times 10. So when x equals 10, y equals what? 40. Finished. Piece of cake. Moving on. Okay. Let's try another problem. Copy this in your notes. You can work ahead and try it on your own, or listen to me, whatever you want to do. X and y vary directly, so as soon as you read this sentence here, you know you're dealing with a direct variation equation. And then I tell you to write the equation that relates x and y, so we know we're going to write a direct variation equation. So as soon as I tell you that, you say to yourself, if I'm going to write a direct variation equation, the constant of variation is the key. Find the constant of variation. So I'm going to use my formula, or my model. There it is. So where the y is, I'm going to substitute 3. Where the x is, I'm going to substitute 7. Got it? 3 equals 7k. Divide both sides by 7. I would not make your constant of variation decimals unless you have to. And sometimes you will when it comes to word problems, okay? And there we go. I found my constant of variation, did I not? Pretty simple if you ask me. So once you know let's go back to my example earlier. Once you know your constant of variation, you simply write y equals, and put the constant of variation right here next to the x for your coefficient. So here's my constant of variation, so here's my answer. There you go. Done. Finished. That is my constant of variation. Alright? Now moving on. I'm sorry guys, that's wrong. Sorry. This is my direct variation equation. Did I write an equation that relates x and y? You bet I did. It's right here. There's my equation. Anytime I ask you to find a direct variation equation, find the constant of variation first and then simply plug it in. Okay? Alright, moving on. Now it says this. Next, find the value of x when y is 22. Okay, no problem. So here's my y right here. Y is 22, so for y I'm going to put 22 equals 3/7 x. Now divide both sides by 3/7. You guys are big students, you know how to do that, it's not a big deal. These cancel. We know how to divide fractions and whole numbers. I mean, we should. Right now I'm homeschooling my 5th grader, he knows how to do that, so it's no problem. I have 22 up top, right? So 22 divided by what fraction? 3/7. This means divide right here, okay? So 22 divided by 3/7. We know how to do this. Put your whole number over what? 1. Change the division to multiplication. Flip your fraction. And you'll get 154 over 3. So there's your answer. When y equals 22, x equals 154 over 3. Now, if you want to write that as a mixed number, that's fine. This is fine for an answer, or you can put 51 1/3. I have no problem with that. Or 51.3. Repeating, I have no problem with that. Okay? Any of those answers are fine. Now let's throw in a word problem, okay? Please copy this in your notes. You'll probably want to pause the video and copy it down. The length of the tail of an alligator, look what it does. It varies directly with the length of the body. Approximately, so it's not always exact, but approximately. Now guys, listen to me say this again, this is so important. The tail varies directly with the body. We're going to come back to that later. But as soon as you see that something varies directly with something, you know right away you're dealing with a what? A direct variation equation. Do you understand me? You should see that right away as soon as you see the words something varies directly with something, you know you're dealing with a direct variation equation. If the length of the tail of an alligator is 3.99 feet and the body is 4.28 feet, write an oh, look at this. Look what it says. Write an equation that relates the what? The body and the tail. Now hold it. What do we know about the body and the tail? What do? They vary directly. So if I'm going to write an equation that relates the body and the tail, then I know I'm going to write a direct variation equation because the tail and the body vary directly. So take this sentence right here, or this phrase if you will. Take this phrase right here. that phrase right there, and let's write it down here like it's an equation. Are you ready? The tail, I'm going to put T, varies directly, so equals K. What's it vary directly with? The body. Now you have to go in order as it says it, or you'll get your B and your T turned around. Now relax. I know you guys are used to Y and X. I get that. But when it comes to word problems, I think it's a lot better to use the actual letters that we're dealing with, because that way we know that this is where the tail goes, this is where the body goes. So, Mr. Error, where'd you get this from? Guys, I got it right here from this phrase, the tail. So I put a T, varies directly, so I put it equals then a K, with the body, B. There you go. Now guys, what if I drew it into your heads? If you're going to write a direct variation equation, what's the first thing you need to find? The constant of variation. Can we do that, Mr. Error? Well, sure we can. Look right here. They give you the length of the tail. When the tail is 3.99, when the tail is 3.99, the body is 4.28. Look at that. Of course, K times 4.28 would be 4.28K. Now divide both sides by 4.28. So divide by 4.28. Divide by 4.28. Let me grab my handy dandy calculator here and type into it. Hold on 1 second, please. Now this is one of these instances where you will want a decimal for your constant of variation. So 3.99 divided by 4.28. Sometimes in word problems you'll have decimals, and that's fine. You're going to get 0.932 approximately. So 0.932 approximately equals your K. So guys, you found your constant of variation. If you found it, then go ahead and write your equation. So T equals, here's your K, we're going to put 0.932. Now I know you guys are used to putting Y and X like this, but in a word problem, use variables that match what you're dealing with, okay? So I did it. Step 1 is done. Write your equation. I did it. So there's your answer. Got it? Now moving on. After you have done this, now look at this next part here, guys. It's very important. Look at this. It's so cool how we can do this. Watch this, please. After you have done this, find the length of the tail when the body is 6.38. So the body is how long? 6.38. So put that in for B. So T equals 0.932 times 6.38. Do you see how helpful this equation is? If I know the length of the tail, I can find the length of the body. Or if I know the length of the body, I can find the length of the tail. So the body is 6.38 feet. I put that in for B. Let me grab my calculator real quick here. So I have 0.932 times 6.38. And I'm going to get 5.95. If you round correctly, I'll put approximately here. Approximately 5.95 feet. And there's your answer. Now, you can round wherever you want to. That's not a big deal to me, okay? But the point is that's how you would find the length of the tail. It's really, really cool. Okay? Alright, moving on now. Lastly, let's go backwards. I'm going to give you some information and you're going to decide whether or not the relationship is direct variation, okay? So instead of me telling you, here's direct variation, find the equation, now I'm going backwards, I'm giving you the information, you're going to tell me, yes, that relationship is direct variation, or no, it's not. Before we do that, though, I think it's best for me to give you an example of a direct variation equation and show you a pattern that exists. So would you please copy this in your notes? Let's pretend I have this for my direct variation equation. Y equals 2x, okay? Let's very quickly get some ordered pairs for this, shall we? Just take some notes, just watch right now. I'm not teaching you anything. I'm just trying to show you a pattern, okay? So in your notes, please write down this direct variation equation. Got it? Next, let's get some ordered pairs pairs. For example, I'm going to put in the number 1 for x, and if I put in a 1 right here, 2 times 1 is 2. I'm going to put in 5, let's say. Let's put a 5 in for x. 2 times 5 is 10. Okay? Now, let's say I put 8 in for x and x. Put an 8. I'm just picking these numbers at random. It really doesn't matter what numbers you pick. Okay? Put an 8 in for x. 2 times 8 is 16. Got it? Now here's the pattern I want to show you. Let's say you put your x over your y. X over y is 1 half. 5 over 10 reduces to 1 half. 8 over 16 reduces to 1 half. So anytime you put x over y, you get the exact same number every single time if you have direct variation. And by the way, you could also do y over x, it doesn't matter. Y over x would be 2 over 1, which is 2. Y over x would be 10 over 5, which is what? 2. Y over x would be 16 over 8, which is 2. Notice I got out 3 identical numbers. When that happens, you know that you have direct variation, so you can use this model, x over y, or you can use this model. You do not have to do both models. You can do one or the other. Okay? Now, moving on, let's apply this and we're finally finished. Okay, here it is. Let's take these ordered pairs. Please copy them in your notes. Let's decide if they belong to an equation that has direct variation. Okay? So here we go. We're going to say yes or no, we have direct variation. So here we go. What I just teach you to do, you can do x over y if you want. So x over y would be 2 over 6, which reduces to 1/3. 4 over 12, which reduces to 1/3. And then 1 over 4, which is 1/4. Oh, we got a problem, don't we? Are all of the numbers identical right here? No. So this relationship does not have direct variation. It does not. You don't have to do this, but let's do y over x just for the fun of it, because it really doesn't matter which way you do it. Let's do y over x. Y over x would be 6 over 2. 6 over 2, which is 3. Or it would be 12 over 4, which is 3. Or 4 over 1, which is 4. Are all 3 numbers identical? No. So these ordered pairs do not relate directly. In other words, they do not have direct variation. Okay? Guys, I hope this has made sense to you. If you have any questions, don't hesitate to call or email.